Chapter 1. Introduction to Solid Principles. Ever wondered how to design maintainable and robust software? Today we're diving into the solid principles. These aren't just some random acronyms, but rather fundamental guidelines for designing software that is not only robust, but also easy to maintain and extend. Chapter 2. Single Responsibility Principle, SRP. First up is the Single Responsibility Principle, or SRP. It's pretty straightforward. Each class should have one and only one reason to change. Think of it like this. If you have a class called Book, its only job should be handling book-related logic, like storing book details. If you need to change how books are stored, you only have to modify this one class. This way, the class does not become a jack of all trades and is easier to manage. Chapter 3. Open-Closed Principle, OCP. Next, we have the Open-Closed Principle, or OCP. This principle says that a class should be open for extension, but closed for modification. So if you have a payment processor class and you need to add new payment methods, you create new classes like credit card processor or PayPal processor that extend the payment processor class instead of changing the existing one. Chapter 4. Liskov Substitution Principle, LSP. The third principle, the Liskov Substitution Principle, or LSP, might sound a bit complex, but it's actually quite logical. It simply means that if you have a bird base class and a penguin subclass, you should be able to use the penguin wherever you use the bird without the system behaving differently. This ensures that the system remains consistent, even when using derived classes. Chapter 5. Interface Segregation Principle, ISP. The fourth principle is the Interface Segregation Principle, or ISP. This principle suggests that a class should never be forced to depend on methods it doesn't use. For instance, if you have an employee interface, you could split it into smaller, more specific interfaces like workable and eatable. This way, the classes using these interfaces only need to know about the methods they actually use. Chapter 6. Dependency Inversion Principle, DIP. Finally, there's the Dependency Inversion Principle, or DIPI. This principle states that high-level modules like business logic should not depend directly on low-level modules like database access. Instead, both should depend on abstractions. For example, instead of using a specific database class, you could create a database connection interface and have the high-level modules depend on this abstraction. This promotes loose coupling, making it easier to switch out components without causing a system-wide ripple effect. Chapter 7. Conclusion. So there you have it, the solid principles. Remember, they're not ironclad rules, but guidelines that, when applied wisely, lead to more maintainable and adaptable code. Now go forth and code!